Chapter 3, Part 2, we talk about negative exponents. So we're going to take a look at the problem number 32. And we have a chart. We're given the original expression, this is Part A, 6 to the 5th times 6 to the negative third power. So in class, we wrote this out in factored form, and we said that 6 to the 5th is 6 fives. And then 6 to the negative third power is going to be 3 sixes, but they're going to go in the denominator. Anytime you have a negative exponent, you're going to put that, whatever that is, in the denominator, and you're going to make that positive. So 6 to the 5th actually becomes, 6 to the 5th times 6 to the negative third becomes 6 to the 5th over 6 to the negative third power, 6 to the third power. So what happens, whatever is the same on the top and the bottom, we can cancel out, and we're left with 2 sixes on the top, and that's going to give us 6 squared. Another example, this is part B, is we have w to the 5th power times w to the negative 2 power. So again, if we write that out, that's w in the numerator. But now because this w is raised to the negative 2 power, we're going to move that to the denominator and make that 2 w's. We can cancel out what's on the top and the bottom, and we have 3 w's left over to make w cubed. Part C, we have now 10 to the negative 4th power times 10 to the 5th power. So again, if we write that out in the factored form, we're going to have 10 times 10 times 10 times 10 times 10 times 10. So you have 5 tens. But now that 10 to the negative 4th, we're going to put those 4 tens on the bottom of the fraction. We cancel out whatever's on the top and the bottom, and we have a 10 left over, so that's just going to be 10 to the 1 power, or you can just say 10. There is a connection between these exponents, so if we go back up here and take a look at this 3 and this negative 2, the 5 and the negative 2, and we get an answer of 3. What we're doing is we're subtracting those exponents. Same thing for part C. Negative 4 plus 5 will give us a positive 1. So that is one of our exponent rules. If we're multiplying, we can add the exponents together. Okay, let's take a look at some more examples. This is going to be 33a. We have 6 cubed now over 6 to the 5th. So if we write this out, we'll have 6, 6, 6 on the top, and then 5 sixes on the bottom. And then we want to see what can we cancel out. Well, 3 can go away. They're simplifying to that giant 1. Because nothing's left over on the top, it's going to become a 1. And then in the denominator, we have 2 sixes, which will give us 1 over 6 squared. Part B of that problem is m to the 5th over m to the 6th. So if we write out our m's, we'll have 5 m's in the numerator, 6 m's in the denominator, and then we're going to cancel out whatever's on the top and the bottom. So it leaves us with 1 m in the denominator. So because everything in the numerator is simplified to 1, 1 stays on the top, and then we'll have m left over. The last problem we're going to look at is number 36. And we're going to start with part A. We have in parentheses 5x squared, the whole thing raised to the 3rd power. So in class we talked about writing this in factored form, which means, which means we're going to have 5 times x 3 times. Because whatever's in that parentheses gets multiplied 3 times. And then we can take 5 times 5 times 5, multiply them together to get 125, and then we can add the x's together. 2x's plus 2x's plus 2x's is going to give us 6x's, which will be x to the 6th power. Part B, we have 4x in parentheses squared times 5x squared. So again, I'm going to write this out. So because it says 4x is to the second power, we're going to have two of those. So 4x times 4x, and then times our 5 times x times x. Because this x is squared, we are going to have two of them, but one 5. So we'll take 4 times 4 times 5. So that's 16 times 5, which is 80. And then we'll add the x's together. We have 1, 2, 3, 4 x's. So 80x to the 4th power. The final part for c, we have a squared c to the 11th over a to the 5th c cubed. So I'm going to write it out. I'm going to have my a times a, then I'm going to have my 11 c's, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then in the denominator, my 5 a's. And then I'm going to have my 3 c's, 1, 2, 3. So anything in the numerator and denominator that's the same, we can make that giant 1 and simplify them. So now we have 1, 2, 3, 4, 5, 6, 7, 8 c's left over. And since they're in the numerator, they're going to stay in the numerator. And we have 3 a's left over. And since they're in the denominator, they're going to stay in the denominator to get c to the 8th over a cubed.